All right, let's look at the standard normal table. Um, the standard normal table is available on all of the questions that involve the normal distribution. Of course, this is not the only method to find these probabilities. This is one method, especially if you don't have a calculator handy, or if you prefer this method, you can use it. I recommend using your calculator because it's going to be more accurate and generally faster. But the table is something that a lot of people prefer, or a few people prefer, so I'm going to teach it as well. So looking at this table, you'll notice I'm going to first look at this little illustration up here in the upper right hand corner. When we're talking about this particular table, all of these values, what we're going to do is we're dealing with a standard normal curve, which means our mean is 0 and a standard deviation is 1. And so when we're talking about the standard normal curve, we describe our variable as the z. Generally, when we're talking about a normal curve, we talk about x as the location along here. But when we're dealing with a standard normal curve, we start to call it z. It's just something we tend to do because it's a little bit more information. It's telling us specifically we're talking about where we are on a standard normal curve, not just a normal curve. All right, so what this table tells us is that this will tell us if z is right here. You'll notice the shaded region is the area underneath the curve to the left of z. All of these values here are going to be telling us what is the area to the left of z. So if I wanted to say, let's come down here. If I said, what is the probability that z is less than or equal to negative 1.23. So that is to say, if I had a standard normal distribution here, and here's where z equals 0. It's right at the mean, because I said my mean is when my mean is 0. If I step 1 to the left, that would be a z of negative 1. If I go a little bit further, we get z equals negative 1.23. Okay. So right here, this is z equals negative 1.23. I'm trying to find what is the area to the left of that value underneath the curve. And that's, like I said, what this table is going to tell us. So first off, I'm going to look in the table, and you can see the first two, or the ones place and the tenths place show up on this side over here. And if I'm looking for negative 1.2, let's zoom in on this, you can see negative 1.2 means I'm going to be looking at this column. But there's a bunch of values here. And let's scroll up so I can see what these values each represent. Up towards the top, you can see this first column represents, let's go here, the first column represents a 0 in the hundredths place, then a 1 in the hundredths place, then a 2, then a 3, and so on. So this would be negative 1.20. This is negative 1.21. This is negative 1.21, 2, negative 1.22, and this is negative 1.23. This is the one we're actually looking for, that 0.1093. So the probability that we are to the left of 0.1093, or sorry, the left of negative 1.23 is 0.1093. If I wanted to switch this around, because this chart only tells me the area to the left, well, what is the probability that z is greater than or equal to negative 1.23? Well, let's see. The curve looks like this. This is a sloppy drawing, but oh well. This is negative 1.23 here. This is the area I just found. And we know the total area underneath this curve is 1, because this is just a normal distribution. Basically, z has to occur somewhere in here. It's either going to be to the left of negative 1.23 or to the right of negative 1.23. Quick note here, it can't be exactly equal to negative 1.23 because this is a continuous distribution, and the probability of being exactly any single value is 0. So that's why I can get away with saying greater than or equal to, or I could go just greater than. Either way works. Alright, so the probability that z is greater than negative 1.23, I can just use the complement rule here. I know the probability it's less than negative 1.23 is 0.1093, so the probability it's greater than or equal to is right here, and pull over to my calculator. Let's turn it on. 1 minus 0.1093 is 0.8907. So the probability of being to the right of negative 1.23 is there. The probability of being to the left of negative 1.23 is there. This second page is the exact same thing. The second page of the normal distribution, standard normal distribution chart. But you'll notice the only difference here is that my z is now to the right of the mean. Before it was over here somewhere, and we are dealing with negative values of z. For the second page, this is just dealing with positive values of z. You can see here we don't have a negative in front of these values here, but the second page is read exactly the same as the first. So there you can go. You can use this chart to find the probability you're either to the left of a particular value or to the right, and we'll discuss how we can figure out the probability we're between two values and stuff like that a little bit later on.